Hello, students. Today, we are going to tackle a very important topic from your Unit 9, ray optics and optical instruments. We're talking about the reflection of light by spherical mirrors. I know, it can seem a little tricky sometimes, but tension mud low. We're going to break it down so simply, you'll understand it perfectly and be all set for your exams. Okay, so let's start with a really simple question. You've all seen a new shiny steel spoon at home, right? Have you ever looked at your reflection in it? You must have noticed something a bit strange. From one side, your face looks completely upside down. So why on earth does that happen? Let's solve this little mystery today.
And this spoon, it perfectly shows the core problem we're studying. Look here, the inside curve, the side where you'd have your dal or soup, it shows your reflection upside down. We call this inverted. But then, if you flip the spoon over to the outside bulging curve, your reflection is suddenly right side up, or what we call erect.
This whole spoon business is actually the perfect entry point to our main topic. You see, the two sides of the spoon are behaving exactly like the two kinds of spherical mirrors we are about to study. So let's get properly introduced to them. So there are only two types you need to know. First, we have the concave mirror. Its reflecting surface curves inwards, just like a cave. See? It's easy to remember. Concave is like a cave. Now, what does it do to light? It converges the light rays, which basically means it brings them all together to meet at a single point. And the second type, that's the convex mirror. Its surface bulges outwards, and it does the exact opposite. It diverges light rays, meaning it spreads them out. Now, to really understand these mirrors and, more importantly, to solve problems on them, we need to get a few basic terms right. First up is the pole, which we denote with a capital P. Think of it as simply the geometric center of the mirror's shiny surface. It's our main starting point for taking any measurements. Next, we have the center of curvature, or C. Okay, just imagine that our mirror is a small part that we've cut out from a big, hollow glass ball, like a football made of glass. Well, the center of that original big sphere, that's what we call the center of curvature. It basically tells us how much our mirror is curved. And now, for maybe the most important term of all, the principal focus, or F. When light rays come in parallel and hit the mirror, after they reflect, they all meet at this one very special point. This is the meeting point, the focus. For a concave mirror, the rays actually physically meet at F. For a convex mirror, they spread out, but if you trace them backwards, they look like they're all coming from F. So naturally, the distance from our starting point, the pole, P, to this special meeting point, the principal focus, F, is called the focal length. We write it with a small f. And this leads us to a super important relationship from your NCERT book, equation 9.3, which is absolutely crucial for your exams. The focal length is always exactly half of the radius of curvature. Remember, the radius of curvature r is the distance from P to C. So the formula you must remember is F equals r by 2. Guaranteed this will be used in your numericals. All right, with those basic terms now clear in our head, we are ready for the master tool. This is the one formula that's going to help us figure out the exact position and the nature of any image formed by any spherical mirror. Let's look at the mirror formula. But wait, before we even touch the formula, we have to learn the rules of the game. And let me tell you, this is the most important part. If you get this wrong, your whole answer will be wrong, even if you use the right formula. It's the Cartesian sign convention. It's actually very simple. Rule 1, all distances are measured from the pole. Rule 2, the direction of the incoming light is positive. Anything measured opposite to that is negative. And Rule 3, heights measured up are positive and heights measured down are negative. It's exactly like the XY axis you use in maths. Now take a look at this diagram. It's straight from your textbook. It shows an object, AB, placed in front of a concave mirror. You can see the light rays leaving the object, hitting the mirror, and after reflection, they form an image, A', B'. The diagram shows the object distance U, the image distance V, and the focal length F. This picture is exactly what our formula is going to help us calculate with numbers. And here it is, the mirror equation, equation 9.7 from your NCERT book. It says 1 upon V plus 1 upon U equals 1 upon F. Here, U is the object's distance from the mirror, V is the image's distance, and F is the focal length. The amazing thing is, if you know any two of these, you can always find the third one.
This single formula, as long as you use it with the correct sign convention, can solve any spherical mirror problem you'll ever get.
Let's just quickly test this out with a simple example from NCERT. Suppose an object is placed 10 centimeters from a concave mirror that has a radius of curvature of 15 centimeters. Okay, step 1. Write down what's given with the correct signs. The object is in front of the mirror, so U is minus 10 centimeters. For a concave mirror, the center of curvature is also in front, so R is minus 15 centimeters. Step 2. Calculate the focal length. F is R by 2, so that's minus 7.5 centimeters. Step 3. Now just plug these values into the mirror formula. 1 by V plus 1 by minus 10 equals 1 by minus 7.5. And step 4. Just do the simple math and solve for V. And what do you get? You get V equals minus 30 centimeters. The minus sign just tells us that the image is formed on the same side as the object. See, it's really that easy.
Okay, now for a very, very important section. I'm going to tell you about the silent killers. These are the small, common mistakes where students lose marks, even when they know the whole topic. So pay very close attention if you want to avoid these exam traps.
The number one silent killer, the mistake almost everyone makes at some point, is getting the sign of the focal length wrong. Please, I want you to write this down and remember it forever. For a concave mirror, the focal length f is always negative, and for a convex mirror, the focal length f is always positive. The second you read the words concave mirror in a question, the very first thing you should write down is that f is going to be negative. This is a non-negotiable rule, okay? And look, if you ever feel confused during exam pressure, here's a simple trick to remember this. A concave mirror is shaped inwards, right? Like a cave. So it pushes the reflected light rays inwards. And on our sign convention diagrams, the inward direction, to the left, is the negative direction. So you see, concave goes inwards, and inwards is negative. Simple. All right, one last little concept, linear magnification, which we call M. This formula is super useful because it tells you two things about the image at once. First, how big or small it is compared to the object, and second, its nature. Is it upright or is it upside down? The formula, straight from NCERT equation 9.9, is m equals h dash by h, which is also equal to minus v by u. Please do not forget that minus sign. It is very important.
So what do we do with this m value after we calculate it? Well, the whole secret is hidden in its sign. If your calculated value for m comes out to be negative, it means the image is real and inverted. Ulta hai to real hai. Simple. If your m value is positive, it means the image is virtual and erect. Seedha hai to virtual hai. Just by looking at the sign, you can instantly tell the nature of the image.
All right, that was quite a bit of information, but I really hope it's all crystal clear now. Let's do a super fast summary of the most important exam-safe points to really lock them into your memory, and then we'll see what's coming up next. So here are your key takeaways. 1. There are two types of mirrors, concave, which converges light, and convex, which diverges. 2. The sign convention is king. You have to follow its rules no matter what. 3. The master formula is 1 upon v plus 1 upon u equals 1 upon f. 4. Magnification m is minus v by u. A negative m means a real and inverted image. A positive m means virtual and erect. And finally, the golden rule. For a concave mirror, f is negative. For a convex mirror, f is positive. Bess, that's it. That's the whole chapter. So our little spoon mystery is finally solved. The inside curve acts like a concave mirror, which, as we know, can form a real inverted image. And the outside acts like a convex mirror, which always forms an erect image. So we've understood reflection, how light bounces off a surface. But you know, that brings up a new question. What happens when light doesn't bounce off, but actually passes through something transparent, like a glass of water or the lens in a camera? Well, that phenomenon is called refraction, and that's exactly what we'll explore in our next explainer. I'll see you then.